Hello everyone. This second video on the basics of probability will now focus on different type of questions that could come in an exam related with the general probability formula, mutually exclusive events, independent events, set notation, and so on. Now let's look at the first example. Two events are such that probability of A is 60%, probability of B is 20%, probability of A and B happening at the same time, intersection, is 0.1, which means 10%. The examiner is asking in the first part, are these two events mutually exclusive? 1 mark for stating yes or no, 1 mark for giving the rationale, the reason. For mutually exclusive events, we know that the intersection should be 0. Since the intersection is not 0, therefore the two events are not mutually exclusive. Let's move to the second part. Are these two events independent? What is the statistical formula for independent events? The formula is, if the individual probabilities multiply out to give you the intersection part, then the two events are independent, otherwise not. 0.6 into 0.2. Does that multiply to give you 0.1? The answer is no. It's not a matter of close by. It's not a matter of rounding up. It's a matter of being exact. If it does not give you exactly the same answer, that means the two events are not independent. Now the examiner can ask you to illustrate whatever info is given to you on a Venn diagram. Simple. Just draw a rectangle for the universal set. Label one of the circle as set A, the other circle is set B. We always start with the intersection, which is 0.1. What would be A only? That would be 0.6 minus 0.1, which is 0.5. Similarly, what would be B only? That would be 20% minus 10%. 0.2 minus 0.1, which is 0.1. How much probability have you accumulated in these two circles combined? So 0.5, 0.1, 0.1, which is 0.7. That means what are you left with? 0.3. That is exactly what the examiner has asked for. By drawing a Venn diagram or otherwise, find the probability that neither A nor B occurs, which in set notation means A union B, the whole thing complement. Now let's look at another question that's slightly trickier than this one, but using the same basic principles. Two events A and B are such. Probability of A, it's denoted by a symbol P. Probability of B is 0.5. Probability of A or B or both. What does it mean in set notation? A union B. Find the value of P if A and B are mutually exclusive. Mutually exclusive, just remember the phrase simple addition. There is nothing to subtract. So 0.5 plus P should equal 0.8. Therefore, P comes out to be 0.3. Second part, which is of course not related with the first part, that's independent of the first part. What happens if the two events are independent? The general formula still holds. A and B is not given in the question. The answer is, can you evaluate it? The answer is yes, you can evaluate it by multiplying the individual probabilities. Probability A union B, that's probability of A plus probability of B minus the intersection. Intersection, because it's independent, you can multiply out the probabilities. So therefore, you apply things where they belong, you write things where they belong, and P comes out to be 3 over 5. If the fraction is exact, you can also write in decimals. Otherwise, you have to worry about the level of accuracy. Question number 3. In a group of 30 students, all students study at least one of the following subjects, physics and bio. That means outside of the two circles and in the rectangle of the universal set, there exists nothing. No one belongs to that particular part, which is outside of the two circles and in the rectangle. So 20 attend physics class, 21 attend bio. It does not say only. That means there are some who are attending both, which also makes natural sense. The reason being, There are 30 students in the class. So 20 plus 21 adds up to 41. How come there are 11 extra? There is no one extra in that class. The counting is perfect. The register is perfect. It's just that there are some people who are taking both the subject. So that number is X. Therefore, only physics, 20 minus X. Only bio, 21 minus X. And everything added together should equal to 30. Therefore, X comes out to be 11. Therefore, there are 11 people taking both the subject. What is the probability? Probability is 11 over 30. Can you do this question using the formula? Yes, if you want to. Probability P union B, that's probability of P plus probability of B minus the intersection. And this time intersection is what you are looking for. Probability of physics or bio is simply 1 because everyone takes one of the two subjects. Instead of writing 1, I wrote 30 over 30 so that all the fractions have a common denominator of 30, leaving the answer of intersection as 11 over 30. So whatever method you feel like, that's easy for you, whether it's the Venn diagram or the formula. By the way, the formula came from the Venn diagram. So these are not two separate entities. Let's look at another question, a question about cats and dogs. There are 100 people altogether, 40 own a cat, 25 own a dog, 15 own both a cat and a dog, and then it's asking few questions. Before you can answer them, you have to fill in the Venn diagram. 15 goes in the middle. 40 minus 15 is 25. That means 25 people own only a cat. And 10 people own only a dog. And 15 people own both. And these three numbers add up to 50. That means there are 50 other people who own no pet, whether it's a dog or a cat. It could be something else, but they are asking about dogs and cats. And these 50 people, which are outside of the two circles, but those are the people who took part in the survey, they don't have either a dog or a cat in their home. Now look at the first part. Owns a dog or a cat, that's simply add 25, 15, 10 and divide it by 50. You don't have to use a formula for such an easy task. Owns a dog or a cat, but not both. That means only dog, only cat. That's only 25 and only 10. That is 35 over 100. Part C. Now this is conditional probability. The phrase that comes after the word given, that is the condition. That now you're not taking a fraction, you're not taking something out of the total. Whatever is written after given, that should be the denominator. You would be taking out of that condition. Given that he owns a cat, how many people own a cat? 40. But what made up the number 40? 25 people, cat only, 15 people, both pets. So therefore the denominator, I'm writing as 25 plus 15. Out of these people, how many own a dog? Of course, it would be the one which own a cat already. So it would be these 15 people. So 15 goes up in the numerator. Whatever is the condition, condition goes down. Something relevant out of condition goes up. Keep it as simple as this. Last part, does not own a cat, given that he owns a dog. Whenever a question of conditional probability comes, always read the portion after given first and then the rest of the question. I'll read it this way. Given that he owns a dog, what is the probability he does not own a cat? This sounds simpler. Given he owns a dog, 15 plus 10, that forms the denominator. And this time he does not own a cat. That means he is a person who owns a dog only. How many people are like that? That's 10. So 10 over 25 is the answer. So the key of doing a probability question successfully, it's basically about reading and comprehension. And then deciding what the numerator is, and then worry about deciding what the denominator is, and then worry about the numerator. Do not worry about the fact whether you have to reduce the fraction, whether you have to write in the unsimplified form or the simplified form or the decimals. These things are, keep it for the last. These are irrelevant as far as you are doing a probability question. Now, the last question. The probability that the person is left-handed is 1 over 6. There are 20 people in that class, out of which 5 are men. So probability of choosing a men or a male is 5 over 20. Now here is the key sentence. Assuming that left-handedness is independent of the sex of a person, find the probability the person chosen is a man or is left-handed. Now the key thing is being independent. So probability L and M should be a product of the individual probabilities. Once you obtain this probability, which you can only obtain because of the fact that the word independent is written, apply the general formula, probability M or L, probability of being a male or left-handed. The person could simply be a male, this person could simply be left-handed, or there are some males who are left-handed. So simply apply the formula and the answer comes out to be 3 over 8. So I hope these 2 videos about the basic probability must have cleared your concepts in a full totality.